Tomorrow, NASA is getting a Christmas gift decades in the making. They're finally expected to launch the James Webb Telescope into space. It's not just the biggest and most powerful telescope NASA has ever constructed. It also could answer some of the biggest questions we have about our universe and how it began. CNN's Kristen Fisher is here with more on this. It's like no small feat, just, answer the questions of the universe. I mean, everything about this, Kristen, is fascinating. What is going to happen tomorrow?
Kate, this launch is about as high stakes as it gets for NASA. If, heaven forbid, something goes wrong tomorrow, that is more than 2 decades, $10 billion down the drain, just like that. It would be a huge embarrassment for NASA and just a massive blow to astronomers all over the world. But if it goes well, and NASA believes that it will, this telescope could truly transform our understanding of the universe and can answer questions like, where did that very first light in the cosmos come from? And are we alone in the universe? Here's NASA Administrator Bill Nelson on our air just this morning.
It's 100 times more powerful than the Hubble Space Telescope, which has brought all this revelation to us. Yes, it's a time machine, Jim. It looks back and captures the light shortly after the Big Bang, and that's over 13 billion years ago that light in the formation of the first galaxy has been traveling to us.
So you hear Senator Nelson talking about how the Webb telescope is 100 times more powerful than the Hubble telescope. So this is essentially like going from the camera quality on an old flip phone to an iPhone 13, right? I mean, it's just going to be a massive, massive upgrade in terms of the kinds of images and light that this telescope can see. But another big difference, and this is where the Webb telescope is at a bit of a disadvantage. Remember, the Hubble telescope had some issues early on, and astronauts had to go and repair it. The Webb telescope is going to be so far away that no astronauts can go and fix it. So that's why not just the launch tomorrow, but the many days afterwards as this telescope sort of unfurls, why NASA and the entire global astronomer community is going to be watching this really on pins and needles, Kate.
Absolutely. Thanks, Kristen. Really appreciate it. Okay, so for more on this, someone who knows more about this than most, one of the people behind this extraordinary effort, NASA's Director of Sciences and Exploration, Mark Clampin. Thank you for being here. We heard NASA Administrator talking about kind of what the mission is, but how do you describe what the mission of Webb is?
So I would say that Webb is, as you heard, the largest space telescope that NASA's ever flown. Another key thing to remember is that it's also working in a new part of the electromagnetic spectrum. So Hubble sees in the visible, Webb will see in infrared, which is heat radiation. So it will open up with its profound sensitivity, a whole new sort of vision or visibility into the universe that we haven't had before. So as you heard, we want to understand how the very first galaxies formed in the universe and then track how the universe has evolved over time. We also want to be able to understand how stars are born. And also more, as we've learned more recently in the last 2 decades, there are now lots of stars that have planets. And we really want to start studying in some detail the atmospheres of those planets so we can start to understand what kind of conditions we need to look for in order to understand if planets are habitable in the future.
This is the largest mirror NASA has ever built. We're seeing video of it, and I love the depiction of it in your background, the background of your shot as well. I wish you could reach out and just touch it. But can you explain why it requires such an enormous mirror, and how do you ensure that you can keep it safe as it is launching into space?
So the reason we require a big mirror is because we need more collecting area. The bigger the mirror, the more light you collect and the fainter the objects that you can see. So that's the first thing. How do we keep it safe during launch? Well, on this particular telescope, it's got so big now, in terms of the requirements astronomers have to do their science, that we can't fit these telescopes into a rocket anymore when they're fully unfolded. So for Webb, we've actually gone in a very new direction, and we are actually folding up the whole package for launch so that it will fit in the rocket fairing. And then after launch, we will unpack the telescope. And as you can see from that image in my background, the mirror is not one single mirror. It's actually 18 segments, all hexagonal. And they're all packed together, and we can basically fold the edge elements around the side of the telescope and the instrument package so that it fits. So that's a very new approach to doing this.
It's just fascinating. I mean, this was first imagined, as I was reading, as a successor to Hubble in '89. So, and this took thousands of scientists, technicians, engineers, 14 countries, I think I saw, to build this. What does this launch represent?
So I think this launch represents a lot of things. First of all, it's a technological marvel. We didn't get into it, but this telescope, because it's infrared, has to work at very cold temperatures. So we've also had to devise new technologies to keep the telescope and the instrument cold for the duration of the mission. The mission's also a testament to, our partnerships, NASA's partnerships with the European Space Agency and the Canadian Space Agency, our partners. And finally, it's just a testament to the commitment of all the scientists and engineers and program managers who've worked on this program so long to make it a success and have overcome every technical challenge as they've been presented, and then worked very hard to diligently test every component of this telescope to make sure it works the way we want it to work when we get on orbit.
Yeah, resilience at its best is kind of what the result of the James Webb Telescope. Really quickly, we have to go. When are you going to receive the first images back? I mean, this is traveling so far.
So we actually expect to get the first science images about 6 months after launch. And the reason is, as I said, because this is kind of a transformer telescope. So it takes us a while to unpack the telescope or deploy all the pieces. And then we have to do very minute adjustments to each of the mirrors so that they all behave like a single 6.5 meter diameter mirror. So that takes about 6 months in total. And then we'll start to get the first science images. And of course, the whole package also needs to cool down to that very cold minus 400 degrees Fahrenheit.
Remarkable. Thank you so much for coming in, and good luck tomorrow.
Thank you very much.
Really appreciate it. Coming up.